Okay, so we now have the stem and leaf plot, which is another way on how we could present using a table. So a stem and leaf display class, or a stem and leaf plot, is a device for presenting a quantitative data, which is in a graphical format, which is similar also to a histogram. This representation class is to help visualize the shape of the distribution. Okay. By the way, it started from Arthur Bowley way back 1900s, and it is used to analyze exploratory data. So stem plots became known or commonly used after the publication of John Tukey's book in the exploratory data analysis in 1977. So this was a technique used in modern computers for graphic capabilities. Now, how does this method or representation is used? So this stem plot, by the way, class, is a chart type. Okay, it is something we plot a matrix of y values onto a common x axis. So as you can see, we have here a column. Okay, a column which is for two columns only, where the first column represents your stem and your second column represents your leaf. So let's say, for example, that you have your data, which is ages. Okay, so the first digit class, or what we call the leading digit, okay, you will put it in the stem column or the first column, while the leaf column, you will put the trailing digit or the second digit. Like for example, you have collected or you have gathered ages, information regarding ages. So let's say there's 19 years old, we have 10 years old, 6 years old, we have 60 years old, 63 years old, so on. So for you to show it, to represent it, you can use this stem and leaf plot, where you will write all the first digits, or what we call the leading digit, in the stem column. Okay? Like for example, in your respondents, just like what you can see here in the figure, let's say meron 1 year old, 2 year old, 3 year old na respondents, for example lang class, so depende sa study mo. And then you have here your senior citizens, you have 63, 66, ayan. So as you can see here, meron tayong key, o para siyang legend, to show what does these numbers represent. So in this case, it's an age. Okay, so the 6, 3 here, as you can see, 6 and 3, okay, represents 63 years old. So this means that 6 and 6, which means 66 years old, which means that your respondent is 66 years old. Okay, so what is the advantage of this type of representation class? So this type of representation class is somewhat accurate in a sense that you'll be able to show the actual data. They follow the actual value of such data. In this method, we overcome the loss of the actual observations. It's because, class, if you have observed, if we use, let's say for example, a histogram or maybe a bar graph, what can you observe? We can observe that we only use something the rounded off value already. Do you get what I meant? We only use the rounded off. Just like for example, 63. So we don't actually plot the 63, but rather we only get the average, something like that. So in this way, okay, we'll be able to see the actual observation. Okay, so it helps us be overcome that disadvantage. Now, another class when it comes to graphical is this histogram, smooth frequency polygon, ogive, or cumulative frequency polygon in the pie diagram. Okay, but before that, let us first discuss what really is the advantage and what really is graphical representation of data. So it's another way of analyzing numerical data. A graph is some sort of chart, and it is where we represent our statistical data, which are in the form, or it could be a line or maybe a curve. Okay, and of course in these lines and curves there are coordinated points plotted on that surface. So graphs class are used to study the cause and effect, maybe a relationship between two variables, and it helps us to measure the change in one variable when another variable changes by that certain amount. Now, graphs class also enable us in studying both time series, even your frequency distribution table. It's because this graph gives us precise or clear account or precise picture of the problem or the data that you are trying to present, because class graphs are much easier to understand compared with table or the other one, textual. And the other thing is graphical is eye-catching. It's because in graphs you can use colors, right? Figures are really eye-catching, unlike with the words and tables, right? So very eye-catching. But the only disadvantage, or one of the disadvantage of the usage of graphical representation, is that we cannot accurately represent the actual observation, just like what we have mentioned. Okay, so most in the data that are presented here are summarized already or somewhat rounded off already. Okay, we don't present all the data. Okay, we only represent the general, something like that. So there are general principles when it comes to the usage of graphical representation. We have there coordinate axis. Okay, you will observe later in our discussion of the types of the graphs that graphs have two coordinate axes, the x-axis and the y-axis. So the horizontal axis there represents your x-axis, and your vertical axis represents your y-axis. So observe that these two axes are perpendicular with each other, and that they intersect with the origin. So usually in the x-axis, okay, we only use the positive value, which is in the right, and for the y-axis we use the upper. Okay, so if you can observe, it's in the first quadrant of our Cartesian plane, if you're familiar with your algebra. Okay, so there are methods on how we can represent frequency distribution. Okay, just like what we have discussed in the table, we can construct a frequency distribution table. That's usage of tabular, but that table we can represent it using a graph. And one way on how to represent that is by the usage of histogram, or it could be a smooth frequency polygon, an ogive, or the other term is cumulative frequency polygon, and pie diagram. But these are just common graphical methods, but there are lots of graphs and charts that you can use, but it depends on the data that you are trying to represent, because there are certain graphs or charts that are only applicable for maybe numerical, or it could only be used for nominal, level, or category. You cannot use numerical or quantitative, so depends. That's why let us discuss some of this. Let's first discuss the histogram. Okay, histogram is the very common frequency graph. Take note, it is a non-cumulative frequency graph, and it is drawn on a natural scale, which means natural scale. For example, your data is all about ages. So you will have there 63 years old, 70 years old, like that. So the actual value of the age, you will put it there in your graph. When you say scale class, there are data or there are graphs kasi na they only used maybe scaled 1:100, especially if, for example, your data is regarding money. So of course the money can be thousands, it could be millions, right? So it's very inconvenient if we really use the actual amount, like 1,000, 10,000, millions. It's very hard representing it in a graph. That's why other graphs used scales. But in this case, if you use histogram, so you really have to use the natural scale, where your frequency class, as we have discussed, frequency here is graphed in the x-axis, the y-axis rather, the y-axis, while your classes is your x-axis, just like what you can see here. Okay, just like in our example last time here. In our discussion, for example, your classes is 86 to 87. So how many or how much is the frequency? So let's say there are only 2. So looking at your y-axis, so you only have to make a bar. Okay, as you can see, histogram uses a bar as its height. This height represents your frequency, as you can see here. Okay, so you have to measure saan dito yung level ng 2, and then that would be the height of your histogram, which is belonging to that class. Okay, so somewhat as you can see, the height here represents the frequency. Also class, in this type of graph, we may be able to easily distinguish or determine the measure of central tendency. If you could recall, or if you are familiar with measure of central tendency is mean, median, modes. Okay, and we will be discussing measure of central tendency maybe next term. That would be midterm, I guess. Yeah. Okay, so that's all about histogram. Another way is using the frequency polygon. Frequency polygon is the one that shows or displays the data which only uses points. Okay, points that are connected there. Okay, frequency polygon there. So as you can see, the only difference here from histogram is that instead of making a bar out of the intersection of x and y axis, you just draw a line here. Okay, if you could observe here in the bar graph, so the point of intersection between x and y axis is this one, right? This one also for the another class, and this one and this one. Okay, so the point here, take note, the midpoint here will be connected using a line. You follow? So that is what we do here in frequency polygon. So you are trying to determine the midpoint of that class, and then you are connecting the dots or the points from there. So you'll be able to make a graph out of it. So still, class, the height here represents your frequency. Okay, but in this case, we are using the midpoint. Do you get the difference, class? In histogram, we are actually using the classes as our x-axis classes. For example, 86 to 87, 88 to 89, like that, as well as the frequency. But in this case, in the frequency polygon, the y-axis is frequency, but the x-axis here, we represent that we use the midpoint. Okay, the midpoint. Now let's go back with the smooth frequency polygon. So the smooth frequency polygon, class, is somewhat similar with your frequency distribution polygon. Okay, this wipe out the irregularities of your figure, or this is more numerous. So that's why it is called smooth frequency polygon. So you are just to adjust the frequencies, moving or running averages. So you are getting adjusted in your frequency and your class interval. Okay, so the same siya sa frequency polygon natin that we have discussed just earlier. Okay, now another is this ogive, or the other term is cumulative frequency polygon. Okay, so what's the difference between this? This graph also, class, is drawn on a natural scale, and it is used to determine the values of a certain factors. Like, for example, you want to know a median, maybe the quartile, percentile, or your percents or your point measures, or your central tendency. So in this graph, we are trying to trying to use the exact limits of your class intervals, which is shown in your x-axis, and your cumulative frequency in your y-axis. So if you could recall, in our construction of frequency distribution table, we are writing the cumulative frequency there, the less than cumulative frequency. So that's the value that we are using here in the y-axis. Okay, another type of graph that we can use is the Pareto chart. So this is already a chart which is not really commonly used. Okay, but Pareto chart, class, has only a specific situation where you can only use it for categorical data or nominal data, which means that if, for example, your data gathered is a qualitative data, which means that it is not quantitative, obviously. Let's say, for example, your gathered information is, for example, courses, or maybe a gender. Okay, the common is it could be civil status, or it could be program and year. So this category is placed in your x-axis, while the frequency is in your y-axis. As you can see here, in this example, so the category is this one here, this one. Okay, and this y-axis is the frequency. Now, what can you observe, class? It's similar to bar graph, right? It is somewhat similar to bar graph, but the only difference, a bar graph and histogram, the only difference is that it is from highest to lowest. Take note, from highest to lowest. So which means that after determining the frequency Okay? So, kung sino doon yung pinakamataas yung frequency, so yun yung una mong i-graph sa Pareto chart mo. Do you follow? So, from highest to lowest, dapat yung paglagay dito. Now, aside from Pareto chart, we also have here the bar chart, or the other term is the bar graph. So, like you said, it is similar with your histogram. Okay? What can you observe there? So, they are just the same. The only difference is that their x-axis. Take note, in histogram, the x-axis is a number or a classes. While the bar graph, what can you observe? The bar graph is used for category there. It's qualitative data. But they have the same, that the y-axis is corresponds to frequency. But the x-axis, that's where they differ. Okay, so for the bar graph, it is used for qualitative data or category, nominal data, while the classes for for histogram, classes yung x-axis natin, or quantitative data. Okay, but again, they are the same. Another class is the pie chart. Pie chart, or the other term is circle graph. So obviously, this is a graph where you use a circle and then you divide it into portion, and that portions represents the relative frequency, or simply the percentage of your data. So if you could recall, we'll be able to solve for the relative frequency by simply dividing your frequency with the total number of your sample, so F over N. And if you want to express that in percent, so that's already the percent times 100%. Okay, just like in our example here, so the graph uses colors, and the colors have a legend which has a corresponding information there. So the red ones is, what do you call that, Hispanic. The green one represents the white, the blue rather, white, and then the green is African American. So obviously this graph shows the ethnicity of the respondents. Okay, so in here, almost the blue or the red, the red has 45.4%, which covers the majority of the ethnicity, which is the Hispanic. So from this graph or from this chart, you easily can determine the mode, right? The frequencies, kanino or what category yung marami, diba? It's easy for us. That's why, class, we have said that by the usage of graphs and charts, it's easy for the readers to understand the information that you are trying to convey. Another is this time series. Time series, obviously from the term itself, you are trying to present data that occurs over a specific period of time, which is under observation. So in this case, class, for example, in a company, so they want to present the sales, for example, for the past 10 years. So if you can observe, class, here in the x-axis, these are dates. It could be that they have used month and year, or it could be that you just use the year. Let's say 2021, or let's say 1998, 99, 2000, 2001, 2002, so on and so forth. Or in this example, they used the month as well. And this y-axis represents the money, for example. If you can observe, this is already scaled. So they didn't use the actual amount. Like, for example, the actual amount is, let's say, 10 million. So they already scaled this. So it could be, this is already in 100,000 maybe. Okay, so it depends upon the presenter on how he will scale the y-axis or the data that he is trying to present. But again, in time series class, you only use this if you want to represent data which occurs for a specific period of time. Okay, it could be, for example, your study is about enrollment in Garcia College of Technology for the past 10 years. So it could be that you will present the data, enrollment, number of enrollment, and then on that year, on what year. Okay, so that's another example. Another class is by the usage of pictograph or pictures from the term itself. Pictograph, or the other term, is pictogram. So obviously, pictograph is the usage of pictures, actual pictures, to represent or to represent data. So in this case, you'll be needing a legend. In this case, class, we have here a donut used to represent the sales of a certain company, for example. So one donut here, one full donut represents 2 donuts. Okay, that's according to the writer. Okay, well, like I have said, it depends upon you on how you will represent a certain picture. So in this case, he used 1 donut to represent 2 donuts. So that means since, like for example, in the jelly, okay, jelly, by the way, this jelly, sprinkles, custard, original, obviously these are the flavors of the donuts. Okay, so category, it's considered as category. So since in the jelly there are how many? 5. Is it 5? 1, 2, 5. Okay, there are 5 jellies. So since 5 donuts, 5 pictures of donuts. So each donut represents 2 donuts. So that means there are 10 jelly donuts sold. That's just an example, guys. But in here, nagkamali siguro siya. That's why 12 yung nakalagay dito. But actually, in the picture, there's only 5 jelly donuts. Okay. So, pictograph is very common in elementary, for elementary students. Yeah. But of course, you can also use it whenever you are already in the company. It depends upon you. Another class is the scatter plot. Okay, scatter plot, from the term itself, these are dots which are scattered. So you don't draw or you don't connect the plot, the dots or points. Okay, but in this type of graph, dalawa yung pinaplot mo, which are the x and y variables, or 2 variables, kung ano yung variables mo. So in this case, meron tayong as you can see here, hindi siya klaro. Ayan, this one and this one. So this is a qualitative or nominal, and then its value, corresponding value. So as you can see, here in a scatter plot, so ganyan lang siya, saan yung intersection nila. Okay, so this is used, class, for examining the relationship of the 2 variables. Kung magkalapit ba sila or not, something like that. Scatter plot. Okay? So, again, these are some of the graphs and charts that we can use to represent our statistical data. Now, in making or in constructing graph, there are some guidelines or characteristics that we have to remember. Okay? Characteristics of a good graph is because, class, it's not just especially in reporting, right? You cannot just simply make a graph na, okay, eto, gagawa lang ako ng pie graph kasi ganito lang, something like that. Kasi ito yung pinaka-easy. So there are characteristics of a good graph. The first is it should have a title. What is that chart all about? Is that sales? Is that ages? Is that ethnicity? So you have to put a title on it. Let's say, for example, graph 1, ages of the respondents. So from the title itself, you will determine, okay, this graph tells me the ages. Okay, so 60, most of the respondents are senior citizens. Based from this graph, I can conclude that the respondents are almost, most of them are senior citizen. Okay, so it's very important that you include a title. Another is, if you are using scales, okay, if ever, so you have to indicate it also. Like for example, when it comes to money, so like we have mentioned earlier, if we cannot actually use the actual amount, like for example millions or thousands there, so you can use scale. So instead of putting 100,000 to 1 and 6 zeros or 5 zeros, so why not just put 100? So naka-scale siya. So you just put it there na money in thousands. So if you put 100, so it means 100,000. It's because you have included the scale. So you really have to specify it. Okay? Also, the scales should start at 0. So we don't use the negative values because class, the data that we are trying to represent here are real numbers. Okay, that's why there's no negative value, something like that. So we should start at 0. So 0 to the right and 0 to the left, to the upper part for the y-axis. Also, the graph or chart should not disfigure the data. What does it mean? When say disfigure, something changes. Okay? For example, your data shows that most of your respondents are senior citizen. Okay, so your graph should also show the same. It should not show na, ay, ba't konti yung yung portion, let's say, for example, you use the pie chart, no, to represent the ages of the respondents. Eh, di ba sa data mo, maraming senior citizen? Bakit sa graph mo, small lang yung portion niya? So, dapat that your graph should mirror your data. Okay? It should not disfigure it. Also, our x-axis and y-axis should be labeled, properly labeled. What does this x-axis represents? You will put, this x-axis represents the year or the month and the year, for example, or maybe the characteristic of the respondents, for example. The y-axis represents the money, sales yearly, for example. So you really have to label it properly. Another, your graph or chart should not contain unnecessary decorations. You say decorations, it could be that you put animations or maybe design in the background. Do not put it class. It's because, recall, let's say for example in pictograph, right? In pictograph, you are using pictures. So what if in your pictograph, meron ka pang background na, let's say, background na aso o background na nature. So baka the readers might confuse, what does this nature means? What does this tree means? Right? So you don't need, or it should not contain unnecessary decorations, which means that our graph or chart should be as simple as possible. It should only contain the data that we are trying to represent. Although class, no, we can use colors, especially in pie graphs, you can use colors, different colors of course, but it should be simple, much simple as possible. And that's the characteristics of a good graph.